I'm David Hutton of Plastics Today. I'm joined today by Tom Baldock, Sales Manager, and Peter Leary, Technical Sales Engineer at Guill Tool and Engineering. Thanks for joining me. The company's Camlock feature and rotary die design are being showcased at K 2025. Could you explain how these features specifically help manufacturers save time in the extrusion process, and what kind of efficiency improvements could extruders expect?
Yeah, so these are designed for a very quick changeover, and typically, initially this was designed for wire applications, but we have sold them to people who make tubing as well. But the idea is basically to enable a quick changeover, so you can take the die completely apart. Like right now, it's completely apart. You can see the inside, it's very easy to clean, and then to reassemble it again, it only takes a few minutes. The die goes in the front, the tooling goes into the deflector, and then the tip retainer screws in the back, and then the whole thing, the Camlock feature is this feature right here. When you put it in just a quarter of a turn, and it's locked in, and then in the front, we have a threaded on die holder that, as opposed to a die holder that's held together with socket head cap screws, where you have 4, 6, or 8 screws that you'd have to take out or put back in, every time you want to make a change. Same on the rear, so it makes it very quick to change over from one product to another. And there's not a long changeover time for cleaning, because a lot of times when you're doing a product changeover, especially if it's a color change, it takes a long time before you've gotten the old color out and the new color is solid on the new product. So this makes it very, very quick. So it's very economical. The payback on a die like this is very quick, just mainly due to the product changeover time is so greatly reduced.
The single point concentricity extrusion crosshead uses microfine adjustment screws for precise concentricity adjustment. How does this technology compare to traditional adjustment methods, and what specific production challenges does it solve for your customers?
Well, when we get into areas where, the product is very small or very thin wall thickness, and, the precision of the adjustment becomes much more important. So especially in one example is a catheter that's used for neurosurgery in infants, even in unborn infants. It's a 1 micron diameter catheter with a 1/1000th of an inch wall thickness. So it's very, very small. And to make an adjustment, you can't use a conventional adjusting bolt because the thread pitch is way too coarse. So we come up, it's basically a compound adjusting bolt with a thread and a thread, so it greatly reduces. It could have up to like 100-to-1 reduction. So 1 turn of an adjusting bolt would be a very, very small amount of adjustment in the product. And like I say, it's mostly medical applications or other applications that just require really tight tolerances, really small dimensions. So that's the reason we came up with it, and it's been very successful. We've sold a bunch of them. And in addition to that, I think the single point concentricity kind of falls in with that as well, but that's maybe a separate subject.
I have a quick video of the single point I'll share right now. This is just how it works. There's 1 nut rather than the 4 that you normally use, and you move it to the high spot. So it's concentric ring, and it moves the die.
So that's how that works, and we have different variations on that theme. One thing we have found is sometimes when you make the adjustment, the die still might have a tendency to move just because of the dynamics of the polymer flow through the die body. So we have been supplying it with all 4 die bolts. It's just only one is used, to make the adjustment. You rotate it to the high spot, make your adjustment, and then tighten down all 4 so that you hold the die firmly so it can't possibly move.
And our universal cam actually has both features. So it can be used as a normal 4-quadrant concentricity adjust, or you can remove these 4 screws here, and then it will freely spin around. And so you can use it as a single point also.
The company's expanded its testing capabilities with a state-of-the-art rheology lab and test extrusion services. Could you walk us through the typical process when a customer wants to test materials or tools before production, and what insights can they gain from this service?
It is.
If you want, yeah.
Sure. So typically we begin with like a consultation with the customer to find out what their specific goals are, whether they're developing a new product or troubleshooting a current process or just validating design. From there, we get 2 kilograms of material, we bring it into our rheology lab, we analyze it with our plate style rheometer, and then we get the material's flow characteristics, its viscosity, and shear rates. So then we take that information and we put that into our CFD program, which is a computational fluid dynamics. I think I have a picture of that. But once it's in there, we can see how the polymer reacts at their certain process temperatures moving through our products or moving through our designs. And this way we can understand the factors up front and do less machining and iterative processes. We're starting off in a better state. And then after that, some customers may want to go to our extrusion lab where we can run small trials of their material through our products rather than having to send someone out to their facility and shut down their line to do it.
How are the company's latest innovations addressing sustainability challenges in extrusion processes? And what green initiatives are you implementing in your manufacturing operations?
Well, one of the big things is just material savings, and again, depending on what the product is that the customer is running, the challenges can vary, but it's really just mostly regarding waste or scrap. The more we can design our product so that it minimizes that, the better off the customer is. He has less wet waste, less scrap to deal with, and that's really the biggest challenge for us, is just eliminating the waste, making changeover times a lot quicker, just emphasizing all the areas in a process where waste can be created, just to try to minimize or eliminate them.
Higher throughput, less downtime, and we're also reducing energy costs if we can have shorter changeovers and more efficient.
Yeah, energy cost is huge because you're running an extruder, which is a high horsepower, application, and energy costs are really high.
Beyond what visitors will see at your booth, what new developments or strategic directions is the company pursuing in 2026 and beyond?
Well, we have focused on some different markets. We cover a broad range of markets in the industry, automotive and on. But there's been a lot of advancements recently and a lot more demand for medical products. So we've been focusing on that just in the last year or two, and have some new product ideas in the works, and it's finding time to work on that. We've also been very, very busy. We've had record sales years ever since COVID. We've really been busy, and we've had to make some adjustments, and I think we've done a good job of doing that. It has forced us to become much more efficient in the way we manufacture our dies. If COVID hadn't happened, we probably never would have done that, but that really forced us to do that, and we're able to handle a much larger volume of business today than we were 5 or 6 years ago. So that's helped us tremendously.
And lastly, where can attendees find you at K 2025?
Yeah, we're in Hall 1, and we're in booth C90, which is right across the aisle from the Clarion booth. That's the large booth that's in that hall, but that's where we'll be, and we welcome everyone to stop by.